Well, we are going to be looking at types of chemical reactions. So this is actually going to be almost like a review because we've gone through all these different types. So acid base, common acids, they often start with H, your HCl, HBr, HI, H2SO4, HIO3, there's a whole bunch. Common bases, they end in hydroxide, OH, and not NAD, either will make water, either will make either with water or will make water. Oh my goodness, that was tough. As the other. So the idea here is that we've got an acid and a base. You can see the H, you got the OH. You're going to make a salt and water. H with the O in this case, but it's going to be producing water. H with water can make an ion in that sense as acid base. This acts as the base. Again, acid and a kind of a weak base, we're making ions. You're mostly looking for water, but don't think of being combustion. Remember, that's a hydrocarbon, very different. Or look for the hydrogen ion to be moving, right? This moved from the fluorine that it was bonded with to the water. This one moved from the bromine it was with to the NH3 to make NH4. Oxidation reduction, we just looked at those. So this is change in oxidation state in determining your values. So if you start off with two elements, those are easy, 0 to the charges. It's pretty straightforward. When you start off with one of these, you want to look at what these change to, what they started off and ended with. So again, you can see that sulfur was oxidized, oxygen was reduced. In this case, it becomes a little more complicated because you have to identify what these are. Now remember, things like potassium are always going to be +1. So you want to be looking at transition metals, and you want to look at halogens. SO4 is the same in both cases, so it doesn't involve the sulfur or the oxygen in this case, right? And so you can see that iodine has gone from -1 to 0, so it got oxidized. Copper's gone from 2 to 1, it got reduced. Same holds true here, looking at the different values for each of these. They often just look like regular chemical reactions. They can, of course, look like the ones we just looked at with 4.9 that had a whole bunch of positives and solids and aqueuses, but they can also look at this. Remember, they need to have reduction and oxidation. But you can see this is not like acid bases. They don't fit that regard at all. You might look at this one and go, oh no, a hydrogen's not bouncing around. It becomes very different because you also see that two of them did that. So it's not really the same exact idea of oxidation and reduction. I'm sorry, of acids and bases. Precipitation. This one always makes an insoluble compound. Now, if you didn't recall, remember it was sodium, potassium, ammonium, nitrates. All are going to be soluble in there. Let me see if I missed another one here. Sodium, potassium, ammonium, nitrate, salts, all soluble. So given that these are going to be aqueous solutions, look at our options. Sodium salt, soluble, doesn't fit the mold, precipitate. Sodium, soluble, doesn't fit the mold, precipitate. Sodium and nitrate, super soluble, doesn't fit the mold, precipitate. Potassium salt, doesn't soluble, doesn't fit the mold, precipitate. So even if you're not sure which one is, you know the rules of what is soluble, the other one has to be insoluble. All right, so that should really narrow that down, and that aqueous means it can dissolve in water, okay, which means it's going to separate, and you do your net ionic equations from there. Didn't even see that was there. Crazy me. All right, so that is the last of our chemical reactions. So again, you've got your precipitate, your redox, and your acid-base types. Looking at the three, they're quite different. Being able to pick them out is going to be the type of questions that are going to come across. So let me know what questions you have. Catch you on the flip side.